Hello, and welcome to Math with Asna. In this lesson, we'll talk about perpendicular lines. We're going to introduce these types of relationships, and we'll do some examples for proofs. We have 5 theorems here. Let's go through them fairly quickly. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Two lines that form a linear pair, so they're supplementary and they're congruent. What's the only way that angles could be supplementary and congruent? If they are both 90 degrees. So the lines are perpendicular if they are a linear pair of congruent angles. If two lines are perpendicular, then they intersect to form 4 right angles. Let's draw out what that would look like. If two lines are perpendicular, and they intersect to form 4 right angles. The way that we would notate it is I wouldn't put this box on all 4 angles. I would just put it once, and then we can just assume that all the rest of them have to be 90 degrees. Why does this work? Well, if this is 90 degrees, then this is 90 degrees because they're vertical angles. And this is 90 degrees because those form a linear pair. And this is also 90 degrees for many reasons. Vertical angles, linear pair, all of those angles have to be 90 degrees. Third one, if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. Let's draw this out. Two sides of two adjacent acute angles. Two sides, this side and this side, of adjacent acute angles are perpendicular, then the angles are complementary. Because these two sides form a right angle, which means the angles that are contained within that have to be complementary. Fourth one, if a transversal is perpendicular to one of 2 parallel lines, then it is perpendicular to the other. Let's draw this out. Make some space here. If a transversal is perpendicular to one of 2 parallel lines, so I have 2 parallel lines, a transversal is cutting through them, and it's perpendicular to one of the 2 parallel lines, that means it's also perpendicular to the other parallel line. And the last one, in a plane, if 2 lines are perpendicular to the same line, then they are parallel. So I have 2 lines that are perpendicular to the same line. So both of those 2 lines are perpendicular to the same line. That tells me that the lines are parallel. The last 2 theorems are really similar to each other. Let's prove the theorem. If a transversal is perpendicular to one of 2 parallel lines, then it is perpendicular to the other. Let's prove that. I want to always start off by drawing a picture. So I'm going to do that right now. I'm going to draw 2 lines that are parallel. Whoops. And they're cut by a transversal. I'm going to call this line M and this line N, and I'll call this line P. These have to be perpendicular because it says perpendicular to one of 2 parallel lines, and I'm going to call this angle 1. As I work through the proof, I can put in more angles and name them how I want. Start off by our givens. What do we know? A transversal is perpendicular to one of 2 parallel lines. So it's perpendicular, N is perpendicular to P, and these lines are parallel. M is parallel to N. That's my given. So the given is the if portion of your theorem. I want to prove that it's perpendicular to the other. If I'm proving this theorem, I can't use it. So you can't just say, by this theorem, the end result is true. We're trying to prove that the theorem is true, so we can't use it. Let's start off by using our given information. If N is perpendicular to P, what does that tell us? That tells us that the measure of angle 1 is 90 degrees, because that's the definition of perpendicular lines. So definition of perpendicular lines. That's something that I got from that first statement that the lines are perpendicular. Now let's use that M and N are parallel. I'm going to go ahead and call this angle 2 because I want to use one of the 4 types of angles that are associated with parallel lines. If you want to use a different angle, that's totally fine. This just is the one that I'm choosing. If the lines are parallel, then I know the angle 1 has to be congruent to angle 2. These are alternate exterior angles. So the alternate exterior angles theorem. Look really carefully at our step 2 and step 3. The measure of angle 1 is 90. And then I have angle 1 is congruent to angle 2. This is written in algebra world where I'm talking about the measure. This is written in geometry world where I'm talking about congruence. If I'm going to make conclusions about these two statements, they need to be written in the same world. They need to be in the same language. I can't have one written in terms of algebra and one written in terms of geometry. That means I have to take another step and I have to convert from geometry world to algebra world. So instead of saying angle 1 is congruent to angle 2, I would think about what that means. That means that the measure of angle 1 is equal to the measure of angle 2. And now I can notice something, that the measure of angle 1 is in both of those statements. That tells me that these two have to be equal. The measure of angle 2 is 90 degrees. Two things are equal to the same thing. That's transitive property. So transitive property is going to be my reason. Now I've proven that the measure of angle 2 is 90. What does that tell me? That tells me that M is perpendicular to P because of the definition of perpendicular lines. And there is my proof for this theorem. I started off with N and P perpendicular, M and N parallel, and then I worked through to prove that M and P were perpendicular. Let's try another one. If two lines are perpendicular to the same line, then they are parallel to each other. All right, so let's draw 2 lines. And there's a transversal. 2 lines are perpendicular to the same line. I'm going to call this M, call this N, and I'll call this P again. They are perpendicular to P. So M and N are both perpendicular to P. I'm going to call these angles 1 and 2. That's my picture. And let's go ahead and put all that information for our givens. So we have M is perpendicular to P. N is perpendicular to P. That's my given. Took the if portion of the theorem. I want to prove that M and N are parallel. Looking at angles 1 and 2, I can see that those are corresponding angles, which means if I can prove that 1 and 2 are congruent, then I can say that the lines are parallel. Let's just go through step by step. M is perpendicular to P. What does that tell me? That tells me that the measure of angle 1 is 90 degrees. That is the definition of perpendicular lines. Now use your next given. I know that N is also perpendicular to P. What does that tell me? That tells me that the measure of angle 2 is also 90 degrees. For the same reason, definition of perpendicular lines. And now I can see 90 degrees in both of those two statements. That tells me that the measure of angle 1 is equal to the measure of angle 2. Because they're both equal to 90, that means they have to be equal to each other. That is the transitive property. Two things that are equal to the same thing, transitive property. Just like in the last problem, I want to make sure that I am in the right world. Measure of angle 1 and measure of angle 2 are in algebra world. I want to bring them to geometry world because the corresponding angles converse says that the angles are congruent, not that the measures are equal. I'm going to say angle 1 is congruent to angle 2, and that is the definition of congruence to bring me back into geometry world. If the angles are congruent and they're also corresponding angles, that means that the lines, oops, I wrote perpendicular, I meant parallel, are parallel. And this is by the converse of the corresponding angles postulate. So again, when you're proving a theorem, you assume the hypothesis is true, which was all this right here, and you prove that the conclusion is true. If you learned something, please like and subscribe, and stay tuned for more videos.